Good day, grade 11 students. I am Chatelina Buan, a practice teacher of Tarlac State University, taking the Bachelor of Secondary Education major in Mathematics. And in this video lesson, I will be discussing all about the simple annuity and general annuity. So I hope that you will learn from this video lesson. The topic is all about the simple annuity and general annuity. The learners should be able to demonstrates understanding of key concepts of simple and compound interest and simple and general annuities. Investigate, analyze, and solve problems involving simple and compound interest and simple and general annuities using appropriate business and financial instruments, and finds the future value and present value of both simple annuities and general annuities. These are the important terminologies that we should remember because we will encounter these words along with our discussion. First is annuity, or denoted as a sequence of payments made at equal or fixed intervals or periods of time. So, ibig sabihin, kapag sinabing annuity, hindi ito minsanang pagbabayad lang o isang bagsakan, sequence. Kaya, may ilang beses na paulit-ulit kang magbabayad o tinatawag nating installment. Next is payment interval, or denoted as N. It is the time between the successive payments. So, ibig sabihin, yung mga payment interval, it may be daily, monthly, quarterly, semi-annually, and annually. So, kung ilang beses ka nagbabayad. Kung daily ba, kung monthly, quarterly, ibig sabihin 4 times. Quarterly, 4 times a year. Or semi-annually, twice a year, and annually, once a year. Next is term of an annuity, or denoted as T. It is the time between the first payment interval and the last payment interval. Ibig sabihin hanggang kailan mo babayaran yung babayaran. Ibig sabihin kung hanggang kailan mo babayaran ang isang entire payment. Amount of future value of an annuity, or denoted as F, is the sum of future values of all the payments to be made during the entire term of the annuity. So it is the sum of all the future values.
Monthly
And
payment for
lastly, the
car
present
loan
value of an
and
annuity, or
educational
denoted
plan.
as P, it is the sum of present values of all the payments to be made during the entire term of the annuity. So these are the following examples of annuities. One is the rental payment. Another is the monthly pensions. Simple annuity. An annuity where the payment intervals is the same as the interest period. Kapag pagbabayad mo is monthly, ibig sabihin yung interest period niya rin is compounded monthly. So, same lang yung payment interval at yung interest period. Ayan, payment interval is equal to interest period. Kapag ang payment interval is monthly payment, ang interest period din dapat compounded monthly. So this is the formula to solve for the future value of the simple annuity. P times 1 plus R over N raised to N times T, where F is the future value, P is the payment amount or the regular amount, R is the interest rate, N is the number of payments, and T is the time. For our first example, 50,000 deposited every year for 5 years at 8% per year compounded annually. Okay, so this will serve as the illustration of the 50,000 payment every year for 5 years. And we will use this formula. Okay, so let's make equations. Use the cash flow time diagram and compounding interest formula F is equal to P multiplied to 1 plus R over N raised to NT to illustrate the annuity. Okay, so the value of P is the amount payment. The 50,000, R is the rate 8% or in decimal 0.08. Our N is 1 because every year, so every 1 year. And then our T is 5 years. Okay, so let us now find the interest rate. Okay, so now let us find the interest every year. So on first year, 50,000 times 0.08, we will have 4,000 as our interest. So 50,000 plus the 4,000 interest, we will now have 54,000 for our first year. What about on the second year? So now that we already have 54,000 new amount, we will multiply it to the interest rate, which is 8%. So 54,000 times 0.08, we will now have the new interest 4,320. So our new amount, which is 54,000 plus the new interest 4,320, the sum would be 58,320. So our new amount now is 58,320. We will multiply it to our interest rate, which is 0.08, and the new interest would be 4,665.6. Okay, we will add this to 58,320. We now have 62,985.6. This new amount, we will use this to find the new interest. So we will multiply it to the interest rate. We will now have 5,038.8 as our new interest. Okay, this interest, we will add this to our new amount, which is 62,985. We now have 68,024.4. And last, for the last year or for our fifth year, 68,024.4 times 0.08, the interest would be 5,441.95. And then add this to our amount, we now have 73,466.5. Okay, so this is another illustration of the payment for the 5 years. But this time, we now use the formula. So we just substitute the values to this formula. So F is equal to P times 1 plus R over N raised to NT. So our P is 50,000. Okay, 50,000 plus 1 times. Okay, so 50,000 times 1 plus 0.08 over 1 raised to 1 times 1. So for our first year, we have 54,000. And on the second year, we got the same 58,320. And for the third year, we have 62,985.6. Now let us solve for our fifth year. Okay, so 50,000 times 1 plus 0.08 over 1 times raised to 1 times 5. We will get 73,466.5. Therefore, the amount of his savings after 5 years is Therefore, the amount of his savings after 5 years is 73,466.50. Okay, now to find the future value, wherein the sum of future values of all the payments to be made during the entire term of the annuity. So for first year,
We will have the value
54,000. Second year,
316,796.5.
58,320. Third year, 62,985.6. Fourth year, 68,024.4. And for the last year, 73,466.50. If we add all these values, let us have this example number 2. How much money should you invest today in an account that earns 5% compounded monthly in order to withdraw 10,000 every month for 6 months? Okay, so we will use again our formula. So we have 6 months as our payment interval and our interest period is 1 month, 1 month, 1 month, so monthly. Okay, 10,000 for the first month, 10,000 for the second month until on the 6th month. Again, use the cash flow time diagram and compounding interest formula to illustrate the annuity. Okay, the value of our P or the payment amount is 10,000. R is 5% or 0.05 in decimal form. Our N is 1 kasi monthly, every 1 month. And then our T is 6 months at the end of 6 months. So for our first month, the interest would be 500. So 10,000 plus 500, we now have 10,500 for our first month. On the second month, 10,500 times 0.05, the interest would be 525. If we add this, we will have 11,025 on our second month. So are we going to do the same process on this? Or we just have to use the formula? To make our procedure easy, we will now use our formula to find the value on the 6th month. Okay, let us substitute our values in this formula. F is equal to 10,000 times 1 plus 0.05 over 1 raised to 1 times 6. 0.05 over 1 is the same, 0.05 plus 1, we will have 1.05 raised to 6. Okay, so 10,000 times 1.3401. The value would be 13,401. Therefore, the amount of your savings after 6 months will be 13,401. Okay, let us now proceed to general annuity. It refers to an annuity where the length of the payment interval is not the same as the length of the interest compounding period. So the payment interval is not equal or not the same to the interest period. For example, you are having a monthly payment and it is compounded annually. Examples of general annuity: monthly installment of a car, lot, or house with an interest rate that is compounded annually. Paying a debt semi-annually when the interest is compounded monthly. So, there is a difference between the payment interval and the interest period. For our first example, find the amount of an annuity of $400 every 3 months or 1/4 year for 10 years if interest is 8% compounded annually. The solution would be, here the payment interval is every 3 months is different than the interest period because the interest period is compounded annually. And the payment interval is that every 3 months. We must match the interest period to the payment interval. We must find the quarterly rate that is equivalent to 8% compounded annually. Step 1. Using the formula A is equal to P times 1 plus I raised to N, find the value of the first dollar invested at 8% compounded annually after 1 year. Okay, the value of our P is $1. I would be 8% or 0.08, and our N 1 year, so 1. So 1 times 1.08 raised to 1 is 1.08. Next step, let the equivalent 1/4 year rate be I%. Note that the equivalent yearly rate would be 4I%. Now find the value of $1 invested at I% per year per 1/4 year or every 3 months after 1 year. Note that the number 4 or the N is the number of times interest in compounded per year. And the step 3, these two amounts must be equal. Hence, 1 plus I raised to 4 is equal to 1.08. So, i-equate lang. 1 plus I is equal to 4th root of 1.08 is equal to 1.01942657. So the value of our I would be 0.01942657 or 1.942657% per every 3 months or per 1/4 year. Therefore, the equivalent 1/4 year rate is 1.942657% and the equivalent annual rate or nominal rate is 4I is equal to 7.77%. R is the payment amount, which is 400. Our N is 10 times 12 or 120 terms. And I is the value that we get on the last slide. Using the formula, A is equal to R times 1 plus I raised to N minus 1 all over by I. We now substitute our values in this formula. We will have $186,603.56. Hence, the amount of the annuity is $186,603.56. For our second example, find the amount of an annuity of $700 every 6 months or every one half year for 12 years if interest is 6% compounded monthly. So same solution, just like in example number 1. Here the payment interval is 1/2 year is different than the interest period or monthly because the interest period is compounded monthly. The first step is to find the value of the $1 invested at 6% compounded monthly after 1 year. So P would be $1. I is 0.06 over 12 or we will have 0.005 and our N is 12 periods per year. Substituting to the formula, we will have the value of A as 1.061677812. Our second step, let the equivalent 1/2 year rate be I%. Now, find the value of $1 invested at I% per 1/2 year after 1 year. Note that n is equal to 2, the number of times interest is compounded per year. These two amounts must be equal, so i-equate lang. 1 plus I raised to 2 is equal to 1.0616778812. 1 plus I is equal to square root of 1.061677812 equal to, ang square root ng number na nasa loob is 1.030377509. Therefore, the equivalent 1/2 year rate is 3.0377509 per year. Per 1/2 year rather. And the equivalent annual rate or nominal rate is 2I is equal to 6.075518. Imumultiply yung nakuhang I sa 2. So magkakaroon tayo ng 6.077055018%. Okay, substituting to the formula, the value of our R is the payment amount or the periodic payment, which is 700. And our N is 12 times 2. We will have 24 terms, and the value of our I that we have get a while ago. Substituting to the formula, we will have $24,212.83. Hence, the amount of the annuity is $24,212.83. Let us now distinguish the simple and general annuity from the given problems below. Suppose Rodrigo, a high school student, would like to save 5,000 annually in a fund that gives 10% compounded annually. How much is the amount or future value of his savings after 4 years? So we will identify the payment interval and the interest period. This problem is simple annuity. Why? Because the payment interval is annually. And the interest period is annually also. Okay, next. Suppose Rodrigo, a high school student, changed his mind and decided to save 5,000 annually in a fund that gives 10% compounded semi-annually. How much is the amount of future value of his savings after 4 years? Okay, so Rodrigo changed his mind. So what will be the annuity that describes this problem? Is it simple or general? It's general annuity because the payment interval is annually while the interest period is semi-annually. Okay, this illustration is general annuity because, as you can see on the encircled parts, the 2, 6 months and years, this 2 that was encircled is not equal, is not the same. The payment interval is 4 years or annually, and the interest period is semi-annually, every 6 months. Ang interest period. So magkaiba, so it is general annuity. What about this illustration? They have the same. It is simple annuity because the payment interval and the interest period are the same. You win at a lottery and receive 50,000 every month at a rate of 0.2% compounded every year. It is a general annuity. And why? Because the payment interval is monthly and the interest period is compounded every year, so annually. They are not the same, therefore this is a general annuity. They are not the same, therefore this is a general annuity. Barry intends to borrow money as capital for his business. To pay it off, he will pay 10,000 at the end of every month for 5 years. the money is compounded by 5% quarterly. So this one is a general annuity. Because the payment interval is monthly, because it says that he will pay 10,000 at the end of every month. But the money is compounded quarterly. So the payment interval and the interest period is not the same. Therefore, it is a general annuity. Next, AJ, a promising pop star, plans to save money for the future. She will set aside 5,000 at the end of every month and put it on an investment company where her money will grow by 4.5% monthly. She will do this for 20 years. This is a simple annuity. Why? Because the payment interval is monthly. It says that she will set aside 5,000 at the end of every month. So it is monthly. And the interest period is also monthly. It says that her money will grow by 4.5% monthly. Therefore, if it has the same payment interval and interest period, they are the same monthly, it is an example of simple annuity.
Thank you for listening, grade 11 students. I hope that you have learned how to get the future value and the present value of the simple and general annuity, and you have learned how to distinguish the difference between the simple annuity and the general annuity. That's all for today's video lesson. Thank you and God bless.